In this lecture, we are going to look at a simple example of how you can derive from standard exceptions and make your own exceptions compliant with what the C++ standard library is doing. Let's look at a piece of code here. We are going to create a divide by zero exception, and you know what this is going to do? It is going to try and protect us from the crash we might get if we divide by zero for integers in our C++ program. So we are going to derive from std exception. You see, this is what we are doing here. If we go in the documentation of this exception class, we are going to see that the what member function is virtual. So if we derive from it, we need to override this guy, or this is not going to do what we expect. So if we go in the documentation for std exception, we are going to see that the what function is virtual. So we can override it here and really make it work in a way that is specific to the problem that we are solving here. In this case, I have made the decision to just print a message to say that we are just dividing by zero here. But if you want, you can even wrap more information and say what you are dividing by zero. For example, if we have A dividing by B, we can say that we are trying to divide A by B and really make this explicit in our message here. But I opted for using a bunch of non-virtual functions because there is something I want you to practice. We want to practice using a dynamic cast and have access to non-virtual functions through a base pointer that we have initially. And we're going to see how this works in a minute when we hit Visual Studio Code. But this is a simple example of how you can derive from exception classes, and it is nothing you haven't seen. You just have to know which class you are deriving from, and you can learn more information about these exception classes by going to your favorite C++ standard documentation. Now that we know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is deriving from standard exceptions. We can grab our template files and put them in place. Let's do this. And we can put the code in here and open this in Visual Studio Code by dragging and dropping here. We will have our main CPP file and do the usual thing. Let's clean up a little bit. We are going to put in our divide by zero exception class. It is a simple class which is deriving from std exception here. And to have access to this class, we need to include exception. So let's do that. And this is going to do exactly what we want. Now we can try and throw these kinds of exceptions, and we can grab whatever was wrong and print this out if this exception happened to be thrown in our program. To play with this, we can set up a simple function which is going to be dividing the parameters. It is going to take the first parameter and divide that by the second parameter. It is what we do here. So we check and see if the second parameter is a 0. If it is, we are going to throw a divide by zero exception, and we are going to pass in the data here. So the first parameter is going to be plugged in. The second parameter is going to be plugged in. And if we are handling exceptions in our code, we will catch this and extract any piece of information we want. So let's do this. We are going to head over to our main function and put in our piece of code. We are going to call our divide function because we know that it may throw this exception. We are going to try and handle it. And this exception is now part of the standard exception inheritance hierarchy. We can grab it using polymorphism. So you see that what we catch here is an std exception, but we can extract our information if we want. So for example, we can take this exception here and downcast it to a divide by zero exception and have our divide by zero exception pointer here. And we are going to check and see if the cast was successful because this is casting to a pointer. So if our cast here fails, we are going to have a null pointer stored in our pointer, and we can do a null pointer check as we are seeing here. If the cast is successful, we will have all the information we want. We can print out what is wrong, and we can call our non-virtual functions here. And we are able to do this because we did a downcast using our dynamic cast facility from the C++ standard library. We can do something like this, and if we run our program, we're going to see that we have all the information we can wish for. So let's pass this through GCC. The build is going to be good. We can clear and bring our PowerShell window on top. we are going to run the program, and we will see that we are dividing 10 by 0. And this is the information we really want to see if something goes wrong in our program. But notice that we are doing a downcast here, and this is one way we can do things. But this is not good design. We can really make this simple and make all this work as part of polymorphism. What we can do is go back to our class and craft our virtual what function to return what we are trying to divide here. So we can add a simple message and say dividing, and we are going to put this in and say dividing std string. So we can change what we are returning here and put in the data of what we are trying to divide. So let's do this. We're going to say dividing, and we are going to add another thing. And we can make this an std string to make this super easy to work with. So let's make this an std string. And this is going to be an std string. And we are going to concatenate a new message. We are going to say dividing and say std toString. We can do this and take a number and turn that into a string. Let's grab the first parameter, which is MA, and we are going to concatenate this with another string that is saying std string, and put a space and say by. Bear with me if this is not making sense. You are going to see the meaning for this in a minute, and we are going to concatenate something on top of this and say std toString and mb. This is the second thing we are dividing with. And notice that we need to return a const char pointer from this function here. So what we need to do is wrap all this in a pair of parentheses. This is going to give us an std string, and we can call our cstr method to get a const char pointer out of this string here. This is something I just crafted out of the blue here to make this work, and this is going to work just fine. Now, if we have this in, we don't need to do the crazy things we just did to just get the data of what we are trying to divide, because we don't need to go through these non-virtual functions. So there is no reason to do a downcast like we did here. All we can do is say stdcout and say ex and say what, and all this is going to be resolved polymorphically, and this is going to be really cool. Notice that we were able to reduce this to a single liner here, and this is really cool. So let's put in our endl here, and we can try and run the program. Let's pass this through GCC. The build is going to be good, so we can clear and run Rooster, and you are going to see that this is working really well. Divide by 0 detected, and we have exactly the same data we had with this craziness that we did here. So I really wanted you to see different ways to do things, and you will have to make your own choice as to which way you are going to do things based on what you are designing for in your C++ applications. This is really all I had to share in this lecture, showing you a simple example of how we can derive from our standard exceptions and do something really useful. I am going to stop here in this lecture. In the next one, we're going to try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.